So kinematics, lecture number 3, kinematic equation. Let's just revise few things before we start off with this. Number 1, for uniform speed or velocity, acceleration is equal to 0. Speed is distance upon time. Average speed is total distance upon total time. Similarly, velocity is displacement upon time, and average velocity is total displacement upon total time. For uniform accelerating or decelerating bodies, your formula is V is equal to U plus AT. S is equal to UT plus half AT square, or V square minus U square is equal to 2AS. For non-uniform accelerating and decelerating bodies. For non-uniform accelerating and decelerating bodies, we use the differentiation of what? Displacement according to what time? So d upon dt of displacement will give me velocity. D upon dt of velocity gives me acceleration. Integration of velocity gives me displacement, which is S, and integration of acceleration dt gives me velocity plus c. At V max, velocity max, acceleration is equal to 0. At velocity minimum, acceleration is equal to 0. We already know that maximum and minimum, there is no acceleration. Gradient of for displacement, gradient for displacement time graph is velocity. Gradient for velocity time graph is acceleration. Same goes with speed time graph. Area under curve of velocity time graph, even speed time graph, is displacement. Now, these were the pointers we actually worked upon the lecture 1 and lecture 2 as well. So let's just say, let's just create a question for us to understand this. Let's say a particle moves in a straight line. In a straight line. Its displacement t second after leaving the fixed point O is x meters, where x is equal to 1 upon 2 t square plus 1 upon 30 t cube. The question says find number 1 speed of particle when t is equal to 10. Number 2 value of t for which the acceleration of particle is twice its initial acceleration. So now this is your question for the kinetic equation. Let's just work out with the solution of part 1. The speed of the particle when t is equal to 10, you already know that you have the displacement equation. So if we just write down the displacement equation, that is x is equal to 1 upon 2 t square plus 1 upon 30 t cube. So if we just differentiate this, so d upon dt of x is equal to d upon dt of what? 1 up, let's say t upon 2 plus t cube upon 30. So this is going to be, when you differentiate the displacement, you end up having what? V, and your 2 square comes down, 2 cancels, you're left with t plus your cube comes 1 upon 10. So this should be t square upon 10. So when the velocity equation is this, you can easily find out what? You need to find out the speed, right? When t is equal to 10, right? So v is equal to 10 plus 10 square upon 10. Too many tens. So the answer for this will be 20 ms to the power negative 1, right? Then we have part 2. What we need to do in part 2 is, it says the value of t when acceleration of particle is twice the initial acceleration. So at initial acceleration, this will be t0, right? To find out initial acceleration, right? So what does this? V is equal to t plus t square upon 10. So if we differentiate this, what we'll end up having is a is equal to 1 plus t to the power 5. So initial acceleration when t is equal to 0. So a 1 plus 0 upon 5. So a will be what? 1. So this is your initial acceleration. Initial acceleration, because t is what? 0. So when t is equal to 0, now it says that the acceleration of particle is twice. So twice the initial acceleration. Twice the initial acceleration. So 2 times 1 becomes 2. 2 times becomes 1, 2. And we know this, that acceleration is equal to 1 plus t upon 5. So acceleration becomes 2 is equal to 1 plus t upon 5. Your t here becomes what? 5 seconds. So for part 2, The answer is 5 seconds. Okay, Ji. Here's another question. A particle P moves in a straight line that passes through origin O. The velocity at P at time t second is V. When V is equal to 20t minus t cube at time t is equal to 0, the particle is at rest. At point P, whose displacement from 0 is negative 36. Going in the negative direction, find the expression for the displacement. So if I want to have the expression for the displacement, so what we need to do is we'll be integrating V. So V is already given and V is given as 20 t minus t cube, right? So it says t is equal to 0, so automatically V will be 0. But at this time, we know that S is minus 36, considering the question, right? So let's say that S is equal to integration of V dot dt. S is equal to integration of 20t minus t cube. So 20t minus t cube, this should be S is equal to 20 t to the power 2 upon 2 minus t to the power 4 upon 4 plus c. So S will be 10t square minus 10t square minus t to the power 4 upon 4 plus c. Now, obviously, we need to give the answer for c as well. So t is 0 and S is equal to what? Minus 36. C is very important to put. So t is 0 and S is equal to what? 36. So negative 36 is equal to 10, 0 square minus 0 to the power 4 upon 4 plus C. So C becomes what? Negative 36. So the equation, final equation of displacement becomes 10t square minus t to the power 4 upon 4 minus 36. So this is your equation for part 1. Then in part 2, the question clearly says find the displacement of P from origin when T is equal to what? 4. So the displacement equation is there, which is S is equal to 10t square minus t to the power 4 upon 4 minus 36. What do we need? T is equal to what? 4. So just substitute it. T 10 4 square minus 4 to the power 4 upon 4 minus what? 36. So S becomes what? 60 meters. The final part says find the value of T for which the particle is at O. Now, at O, your displacement should be 0, right? That is your origin. Because at O, since that is your starting point, so displacement will be 0. So considering this, let's say at O, your displacement is 0. So the equation that we had was S is equal to 10t square minus t to the power 4 upon 4 minus 36. So we can directly write down as 0, 10t square minus t to the power 4 upon 4 minus 36. Let's solve this. This should be 40t square minus t to the power 4 minus 144 is equal to what? 0. So this will give me two equations together, right? 36 and 4. So t square minus 4 is equal to 0. T square minus 36 is equal to what? 0. T is equal to what? 4. T square is equal to 4. T square is equal to 36. T is equal to 2 and T is equal to what? 6. So the time will be 2 and 6, 2 seconds and 6 seconds. For what? For the value of T for which the particle is at 0. So this was about it from the kinematic equation lecture with two particular examples. Obviously, then more of this will be cleared when we'll be doing the questions.